A quiet line of storms can turn into a fast-moving wall of wind, rain, and lightning when the atmosphere lines everything up just right. Instead of one thunderstorm rising and collapsing on its own, many storm cells join along the same boundary, often near a cold front, dry line, trough, or old outflow boundary. The engine begins when cool air at the surface pushes forward like a wedge. That cool air undercuts warm, humid air ahead of it, forcing the lighter air upward. If the air is unstable enough, that lift breaks through the cap, and deep thunderstorm towers grow quickly along the boundary. As rain and hail fall, they drag air downward and cool it by evaporation and melting. Those downdrafts spread out along the ground and merge into one broad, cold pool. The leading edge of that cold pool is the gust front, and it keeps lifting fresh, warm air into the storm line. This is why a squall line can survive for hours, and sometimes through the night, even after daytime heating fades. Moisture is the fuel. Low-level winds can feed warm, humid air into the line from far ahead, while the rising air condenses water vapor and releases latent heat. That heat strengthens the updrafts, pulling in even more air from below. But a cold pool alone is not enough. If it surges too far ahead, it cuts off the storm's warm inflow and the line weakens. Long-lived squall lines need a balance between the cold pool pushing out and the low-level wind shear pushing back. This idea is known as RKW theory, after Rotunno, Klemp, and Wiseman. When the balance is right, the lift stays deep and upright, so new storm towers keep forming on the leading edge. On the ground, the classic warning sign is a shelf cloud. It looks like a low, wedge-shaped cloud stretching across the horizon, sitting above the gust front. A shelf cloud usually points to straight-line wind danger. A wall cloud is different. It forms beneath a rotating supercell updraft and is more closely linked with tornado risk. On radar, forecasters look for the shape of the line. A straight, bright band can bring strong gusts and heavy rain. If part of the line bulges forward, it becomes a bow echo, often driven by a rear inflow jet crashing into the back of the storms. Several bows can form a line echo wave pattern, a serious signal for damaging winds. Australia has several triggers. Southern states often see squall lines with strong cold fronts, prefrontal troughs and dry lines. In the east, the Great Dividing Range can lift humid air from the Coral and Tasman seas, helping storms break the cap and organise as they move toward the coast. In the tropics, monsoon moisture, sea breezes, easterly jets and cold pools can build huge storm lines that travel for hundreds of kilometres. For communities, the impact is simple. Sudden wind shifts, intense turbulence, heavy rain, lightning, and damaging straight-line gusts. For aviation and road travel, conditions can change within minutes. The key lesson is to watch the sky and the radar together. A shelf cloud, a bowing radar segment, or a fast-moving line of storms means it is time to get indoors, secure loose items, and follow official warnings.